We now have a remarkable and growing body of scientific evidence showing that meditation is not only beneficial for well-being, but it can reshape the brain, regulate stress systems, and enhance cognitive performance. Today, I'll walk you through 5 science-backed signs that meditation is working and how meditation impacts the nervous system, all based on rigorous peer-reviewed data. So you're not just taking it on faith, you're leveraging neuroscience. Let's first address how meditation works on a biological level. When you engage in meditation, particularly focused, attention, or open, monitoring types, you are guiding your attention system in a deliberate way. The key neural systems involved are the prefrontal cortex, which is responsible for executive functions like attention, decision making, and emotional regulation, the default mode network, which becomes less active during meditation, especially during mindfulness practices, and the autonomic nervous system, which includes both sympathetic fight or flight and parasympathetic rest and digest branches. Meditation, over time, shifts the autonomic balance toward parasympathetic dominance. That means better sleep, improved digestion, lower blood pressure, and a more resilient response to stress. In fact, fMRI studies have shown that even after just a few weeks of consistent practice, there is decreased activity in the amygdala, the brain's fear and stress center, and increased connectivity between the prefrontal cortex and limbic structures. So let's now go into the 5 clear neuroscience-based signs that your meditation is working. Meditation is often thought of as a passive practice, just sitting and doing nothing. But when we look at it through the lens of modern neuroscience, something remarkable emerges. Meditation is not passive at all. It is an active training of the brain's most essential circuits. In fact, we now know from structural and functional neuroimaging studies that consistent meditation can reshape the brain in measurable, meaningful ways. One of the core areas impacted by meditation is the prefrontal cortex, the part of the brain involved in attention, executive control, and self-regulation. This area is critical when it comes to focusing on tasks, managing impulses, making decisions, and even regulating emotional reactions. Meditation, particularly focused attention practices, has been shown to increase cortical thickness in the prefrontal region, as well as improve functional connectivity between the prefrontal cortex and deeper brain areas, such as the limbic system. That enhanced communication leads to better emotional control, greater behavioral flexibility, and stronger attentional stability. Another major area that undergoes measurable changes through meditation is the amygdala, the almond-shaped structure deep in the brain responsible for processing fear, anxiety, and emotional salience. Longitudinal MRI studies have demonstrated that individuals who engage in regular mindfulness meditation exhibit reduced amygdala volume and decreased activity in response to emotionally charged stimuli. This means that meditation doesn't just change how you feel in the moment. It alters how your brain responds to stress at a fundamental level. And this is crucial because a hyperactive amygdala is often at the core of chronic anxiety, PTSD, and stress-related burnout. Now, let's talk about the insula, a lesser, known but equally vital part of the brain. The insula is the hub of interoception, your brain's ability to sense what's going on inside your body, heartbeat, breath, gut tension, and other visceral states. Many forms of meditation, especially those involving body scan or breath awareness, activate and strengthen the insular cortex. Over time, this leads to improved mind, body awareness, and self-regulation. People report being more in tune with their bodies, able to detect rising anxiety or tension earlier and regulate it before it becomes overwhelming. And this is not just subjective reporting. It is consistent with activation patterns we see in fMRI scans of experienced meditators. An important takeaway here is that the changes we're discussing are not merely functional, they're structural. Regular meditation leads to neuroplasticity, the brain's capacity to reorganize itself. This includes changes in gray matter density, white matter connectivity, and even cortical thickness. In one widely cited study conducted at Harvard, Participants who practiced mindfulness for just 8 weeks showed increased gray matter in the hippocampus, a region critical for memory and learning, and decreased gray matter in the amygdala, associated with stress and emotional reactivity. And these changes are not just seen in people who have been meditating for decades. Even short-term interventions on the order of 10 to 20 minutes a day for a few weeks can lead to observable changes in the brain. One of the powerful things about meditation is that it operates on both fast and slow timescales. You may feel a reduction in stress during or right after a session, but the long-term effects compound, building new neural circuits and reinforcing healthy patterns of thought and emotion. What we're seeing in the lab is that meditation acts almost like neurological exercise, repetitive, deliberate practice that builds stronger connections between the brain regions involved in attention, awareness, and emotion regulation. And like physical training, consistency is key. Just as one workout won't build muscle, one meditation session won't rewire the brain. But daily practice, even if brief, has an exponential effect. You're not just changing what you pay attention to, you're changing how your brain functions at rest, how it responds to challenges, and how it recovers from stress. So when we talk about meditation reshaping the brain, we're talking about a set of mechanisms that are now well understood in neuroscience: synaptic pruning, dendritic branching, increased myelination, and altered neurochemical pathways. Meditation isn't just a spiritual or philosophical act, it's a biological intervention. And it's one of the few tools we have that's free, accessible, and profoundly effective across a wide range of health outcomes, from anxiety and depression to focus, sleep, and resilience. Emotional reactivity is one of the key drivers of human behavior. When we encounter stressors, whether it's a social confrontation, a sudden sound, or even a negative thought, the body and brain rapidly respond through a cascade of neural and hormonal signals. These reactions are often automatic and driven by deeply ingrained survival mechanisms. However, the ability to create a pause between stimulus and response is not only possible, it's trainable. One of the most effective tools to develop that skill is meditation. At the neurological level, emotional reactivity is largely governed by the limbic system, particularly the amygdala, which plays a central role in threat detection and emotional salience. When the amygdala detects a potential threat, physical or psychological, it sends signals to other brain regions and to the body through the autonomic nervous system. This results in elevated heart rate, increased blood pressure, changes in breathing, and the release of stress hormones like cortisol and adrenaline. In high reactivity individuals or those experiencing chronic stress, the amygdala becomes hypersensitive. It begins to fire in response to non-threatening stimuli, like a minor disagreement or a critical email. Over time, this hyperactivity leads to a decreased ability to regulate emotions, reduced impulse control, and an increased risk of anxiety disorders. Meditation helps recalibrate the emotional response system. Functional MRI studies show that regular meditation leads to decreased activity in the amygdala and increased functional connectivity between the amygdala and the prefrontal cortex, particularly the ventromedial and dorsolateral prefrontal areas, which are involved in emotional regulation, decision making, and executive control. This enhanced connectivity is critical because it allows the top-down regulation of emotional reactions. That means the prefrontal cortex can inhibit or downregulate signals coming from the amygdala, allowing the brain to assess whether a response is appropriate before the body reacts. This is not just theoretical, it's observable. Individuals who meditate regularly report greater emotional stability, fewer impulsive reactions, and more thoughtful, measured responses to stress. In practical terms, this means that someone who might previously have lashed out in anger or spiraled into anxiety is now able to pause, observe the emotional trigger, and choose a more adaptive response. That pause, just a few milliseconds, is everything. It's the space where conscious control is restored, and meditation creates that space by training attention and awareness. Breath, Focused meditation, in particular, is extremely effective in this regard. Focusing on the breath, especially the exhalation, engages the parasympathetic nervous system via the vagus nerve. The parasympathetic system is responsible for calming the body after stress and restoring homeostasis. Each time you bring your attention back to the breath, you're reinforcing neural pathways that favor calm, measured awareness over reactivity. Interestingly, this process also has a strong neurochemical component. Meditation has been shown to increase levels of gamma-aminobutyric acid GABA, an inhibitory neurotransmitter that dampens neuronal excitability. Higher GABA levels are associated with reduced anxiety and greater emotional control. There's also evidence that meditation reduces the baseline levels of norepinephrine, a neurotransmitter linked to vigilance and stress, while increasing levels of dopamine and serotonin, which support mood stability and cognitive flexibility. What's particularly important is that the effects compound over time. Early in a meditation practice, you may not notice dramatic changes in emotional control. But with consistent effort, daily sessions of even 10-20 minutes, you begin to restructure the circuits that control how you respond to life's inevitable challenges. And once those new neural patterns are in place, they tend to persist. This is a principle known as experience-dependent plasticity. The brain changes in response to repeated experiences, and those changes become the default mode over time. It's also worth noting that reduced emotional reactivity doesn't mean emotional suppression, quite the opposite. Meditation helps you become more aware of your emotional landscape, not less. You still feel anger, fear, joy, and sadness, but you're no longer controlled by them. You gain the capacity to witness emotions without immediately reacting, and that witnessing gives rise to genuine freedom in behavior. This shift from reactive to responsive is one of the most powerful outcomes of meditation. It changes the way you relate to others, improves communication, reduces conflict, and increases empathy. In many ways, it's a transformation of not just the nervous system, but of identity itself, from someone who reacts to someone who chooses. That transformation is supported by neurobiology, demonstrated in imaging studies, and achievable for anyone willing to train their brain. And meditation is the tool that makes it possible. Stress is not inherently bad. In fact, short-term stress, when experienced in controlled doses, can enhance focus, increase alertness, and even strengthen the immune response. However, problems arise when we can't effectively shift out of that heightened state. In neuroscience, one of the most critical markers of health isn't whether you experience stress. It's how quickly and efficiently your body and brain recover from it. Meditation, as supported by a growing body of peer-reviewed research, is one of the most reliable tools to accelerate stress recovery by training the nervous system to move out of a high, alert, sympathetic state and return to baseline more efficiently. This shift is observable at both the psychological and physiological levels, and one of the clearest metrics we have for measuring this is heart rate variability HRV. HRV is the variation in time between heartbeats, and while that might sound like a negative thing, it's actually a positive sign of nervous system flexibility. A higher HRV reflects the capacity of the autonomic nervous system to adapt to different challenges, stress, rest, cognitive effort, and so on. It indicates that your system can ramp up when needed and calm down when the threat has passed. Conversely, a low HRV is a strong predictor of poor recovery, chronic stress, and even cardiovascular disease. Meditation, particularly practices that involve slow, deliberate breathing and interoceptive awareness, like mindfulness of breath or body scan techniques, has been shown to increase HRV significantly. This means meditators not only experience stress less intensely over time, they return to calm faster, and this matters immensely when it comes to long-term health and performance. The science behind this centers around the autonomic nervous system, which has two branches: the sympathetic, responsible for mobilizing the body for action, and the parasympathetic, responsible for slowing things down and restoring balance. Meditation activates the parasympathetic system by engaging vagal tone, the activity of the vagus nerve, which extends from the brainstem down to the gut and interfaces with the heart and lungs. Strong vagal tone is associated with greater HRV and better emotional regulation, and meditation increases this tone with consistent practice. A key mechanism here is breath control. When you slow your breathing down to about 5 to 6 breaths per minute, particularly emphasizing the exhale, you're tapping into a powerful lever that directly influences your vagus nerve. This is not just psychological relaxation, it's a biological signal that tells the brain we are safe, which then cascades into lower cortisol production, reduced heart rate, and a calmer mind. Moreover, brain imaging studies show that meditators have greater connectivity between the prefrontal cortex and brainstem structures, such as the aqueductal gray, and the nucleus of the solitary tract areas responsible for coordinating the stress response. This enhanced communication allows for better top-down regulation of physiological arousal. Simply put, the brain becomes better at detecting when the stress is no longer needed and shutting it off appropriately. But here's what's especially compelling. Recovery from stress isn't just about feeling better. It actually preserves energy and cognitive resources. When your system stays in a heightened sympathetic state for too long, it drains glucose, elevates inflammation, and impairs neuroplasticity. By using meditation to reduce the time spent in post-stress activation, you preserve those biological reserves for when they truly matter: problem solving, creative thinking, physical performance, and deep sleep. In studies on high-stress populations such as military personnel, first responders, and individuals with generalized anxiety, those who implemented even short daily meditation practices showed significantly faster return to baseline levels of cortisol, blood pressure, and subjective stress. In some cases, just 12 minutes per day over the course of a few weeks led to measurable shifts in stress recovery profiles. And importantly, meditation not only trains recovery, it builds anticipatory regulation. Over time, meditators don't just bounce back faster, they enter stressful situations with a more balanced baseline, meaning the initial spike in stress is lower to begin with. This is the nervous system becoming more efficient, smarter, more adaptive, and less wasteful. Recovery is where resilience is built. Stress will always occur, but if you can shorten the arc of reactivity, both physiologically and emotionally, you gain an enormous edge. You protect your mental clarity, immune function, and cardiovascular health. Meditation is a biological training tool that fine-tunes this capacity. It's not about escaping stress. It's about returning from it swiftly, effectively, and with strength. And that recovery, when repeated daily, rewires the brain and body for a new default: calm under pressure and clarity after challenge. In the modern environment, the ability to direct and sustain attention has become both rare and incredibly valuable. We're constantly bombarded with digital stimuli, notifications, messages, alerts, each one triggering a brief spike in dopamine and pulling our focus in a different direction. The brain, as adaptive as it is, begins to wire itself for shorter and more fragmented attention cycles. But attention isn't just a mental skill. It's a neural process, and like any process in the brain, it can be trained and strengthened through deliberate practice. One of the most effective and accessible tools for this purpose is meditation. To understand how meditation extends attention span, we need to first break down the biology of attention. At a high level, attention involves the coordinated activity of several brain networks, including the dorsal attention network, the frontoparietal control network, and the default mode network. The dorsal attention network is responsible for goal-directed focus, what you're deliberately paying attention to. The frontoparietal control network modulates this system and helps maintain focus. The default mode network, on the other hand, is active when the mind is wandering, thinking about the past, future, or self. What meditation does, particularly focused attention meditation, is repeatedly activate the dorsal attention network while simultaneously reducing activation in the default mode network. Every time you focus on your breath and gently return your attention when it wanders, You are literally reinforcing the neural circuitry involved in sustained focus. Over time, this repeated pattern induces synaptic plasticity, the strengthening of synapses that support attentional stability and the pruning of those that favor distraction. Functional MRI and EEG studies on experienced meditators show significantly higher activity in the anterior cingulate cortex and the dorsolateral prefrontal cortex, areas involved in monitoring attention and suppressing irrelevant information. In one study, participants who meditated for just 2 weeks showed improved performance on continuous performance tasks, psychological assessments designed to measure sustained attention over time. These individuals not only made fewer errors, but also recovered more quickly after losing focus, a critical component of attentional resilience. Another aspect worth highlighting is the role of neuromodulators, chemicals in the brain that regulate attention and arousal. Dopamine is one of the key players here. It's often associated with reward and pleasure, but in the context of attention, dopamine helps assign value to stimuli, essentially telling the brain, "This is worth focusing on." What's fascinating is that meditation practices, including NSDR nonce, deep rest, and mindfulness, can increase baseline dopamine levels in the striatum. This creates a system where the act of sustained attention becomes inherently more rewarding, making it easier to stick with a task. Meditation also modulates norepinephrine, another neuromodulator involved in alertness and attention. When levels are too low, we become meri and drowi, and INPOE, ITIIECNTIVE, too high, and we become anxious and hyper vigilant. Meditation helps stabilize norepinephrine release, keeping it in an optimal range for task engagement and focus. This balance is especially important for people who struggle with attention deficit tendencies, where the system oscillates between under and overactivation. The breath, again, becomes a central tool in this process. Slow, deliberate breathing, especially with a slightly extended exhale, activates the parasympathetic nervous system, which lowers physiological arousal without inducing sleepiness. This creates the ideal internal state for sustained, relaxed attention. You're awake, alert, but calm, precisely the state required for deep focus and productivity. Now, it's important to understand that these neural and neurochemical changes are dose-dependent. Like physical exercise, meditation works through repetition. The longer and more consistently you practice, the more robust these attention-related adaptations become. Even 5 to 10 minutes a day can start the process, but just like building muscle, real transformation occurs through weeks and months of effort. The good news is that these changes are durable. Once the attentional networks are strengthened, they don't disappear overnight. They become your new cognitive baseline, and unlike stimulants or external hacks, meditation-based attention training comes without a crash. It builds a self-regulating system that is resilient under pressure and less vulnerable to distraction. You become someone who can direct your focus deliberately, return to it quickly when it slips, and engage deeply with whatever you choose to work on, be it a conversation, a creative project, or even just the experience of being present. In a world designed to fracture attention, this is a superpower. It's the difference between a distracted mind constantly pulled by external forces and a focused mind that can choose its direction. Meditation trains that ability from the inside out, using your breath, your awareness, and your biology. It's not about avoiding distraction. It's about training the system to recover quickly and return to center. And with practice, the brain learns that focus isn't just a task. It's a state of being you can access at will. Sleep is not simply the absence of wakefulness. It's a highly active, dynamic process governed by intricate interactions between neurochemicals, brain regions, and circadian rhythms. High-quality sleep plays a vital role in physical recovery, memory consolidation, emotional regulation, and metabolic health. But in modern life, many people experience fragmented or shallow sleep due to chronic stress, irregular schedules, excessive screen exposure, or dysregulated nervous systems. One of the most powerful science. Supported tools for improving sleep architecture and circadian alignment is daily meditation. Sleep begins with the brain's transition from sympathetic nervous system dominance, alert, active, aroused, to parasympathetic dominance, calm, restorative, regenerative. For many individuals, this shift is impaired, either because they bring unresolved cognitive stress into bed or because their nervous system remains hyperactivated. Meditation, particularly practices that emphasize interoceptive awareness and breath control, helps signal to the brain and body that it's safe to downshift into restorative modes. This is measurable through changes in heart rate, variability, HRV, cortisol rhythms, and electrical activity in the brain. One of the most consistent findings in meditation research is that it reduces the latency to sleep onset, the time it takes to fall asleep. This is due to a reduction in cortisol and norepinephrine levels and an increase in GABA, a neurotransmitter that inhibits neural activity and prepares the brain for deeper stages of sleep. Regular meditators report falling asleep faster and waking up fewer times during the night, and these subjective experiences are backed by polysomnographic studies showing greater slow-wave sleep and REM sleep quality. Slow-wave sleep is crucial for physical repair, including hormone regulation and immune function, while REM sleep is key for emotional processing and cognitive integration. When these phases are disrupted by stress or poor sleep hygiene, we feel the impact: immediately reduced focus, heightened emotional reactivity, and lower resilience. Meditation essentially builds the neural infrastructure that promotes smooth transitions between sleep stages and greater sleep efficiency. But beyond the architecture of sleep, there's another layer: circadian timing. The brain contains a structure called the suprachiasmatic nucleus SCN, which functions as the master clock. It synchronizes our internal rhythms, body temperature, hormone release, alertness levels with the external light, dark cycle. This circadian rhythm is deeply tied to the release of melatonin, the hormone that helps initiate sleep. When we expose our eyes to bright artificial light late into the evening or engage in cognitively intense activity just before bed, we delay melatonin onset and shift the circadian phase later. Over time, this disrupts not only sleep quality, but also mood, metabolism, and even gene expression. Meditation helps by quieting the mind and body before bedtime, reducing the risk of circadian misalignment. In fact, specific forms of meditation like body scans, yoga nidra, and NSDR nonce, deep rest, can function as powerful tools to prep the brain for sleep. These practices involve lying down in a dark, quiet room and gradually directing attention through different areas of the body. This not only increases parasympathetic tone, but also serves as a kind of rehearsal for sleep. Brain wave studies show that these protocols guide the brain from high-frequency beta states into slower alpha and even theta activity, precursors to the onset of sleep. What's particularly striking is that these practices can mimic some of the effects of sleep, even when you don't get a full night's rest. For individuals who experience insomnia, jet lag, or shift work sleep disorder, meditation and NSDR protocols can provide partial restoration of cognitive and emotional balance by reducing stress hormones and enhancing dopaminergic tone. Long-term meditators also exhibit more robust circadian rhythms. That means clearer distinctions between wakefulness and sleepiness, higher amplitude of melatonin and cortisol cycles, and better alignment between internal biological time and external demands. This consistency is protective. It improves not only how we sleep, but also how we wake, think, move, and feel throughout the day. There's even evidence that meditation helps decouple cognitive arousal from sleep effort. Many people struggle with sleep not because their body isn't ready to rest, but because the mind is active ruminating, planning, worrying. Meditation trains the brain to observe those thoughts without attachment, reducing their impact and lowering pre-sleep arousal. This is one of the reasons why mindfulness-based interventions are increasingly used in clinical settings to treat insomnia. Sleep is a fundamental pillar of health, and meditation is a tool that interacts with it on multiple levels, from physiology to psychology to circadian biology. It doesn't replace sleep, but it enhances the conditions necessary for high-quality rest. And when practiced consistently, it can restore the rhythms that our environment and habits so often disrupt. Self-awareness is the foundation of behavior change. Without it, we remain reactive, driven by habits, biases, and unconscious emotional triggers. But when we train the brain to observe our thoughts and internal states without immediately acting on them, we gain a kind of cognitive leverage, the ability to pause, assess, and choose. Meditation, specifically forms that emphasize internal observation like mindfulness and open, monitoring practices, is one of the most scientifically validated methods for enhancing self-awareness and improving emotional regulation. In neuroscience, this capacity is rooted in a process called interoception, the brain's ability to sense the internal state of the body. This includes sensations like heart rate, breathing, muscle tension, and gut feelings. The insula, a region deep within the cerebral cortex, is central to this system. It integrates signals from the body and allows us to form a coherent sense of what we're feeling and how intensely we're feeling it. Experienced meditators show increased insular thickness and connectivity, markers of more refined internal awareness. When people begin meditating, one of the first things they notice is how chaotic their inner world can be. Thoughts arise spontaneously, emotions shift rapidly, cravings or aversions appear out of nowhere. Instead of suppressing these experiences, meditation teaches the brain to witness them, to observe without judgment or immediate reaction. That gap between stimulus and response is critical. It's in that space where neuroplasticity, the brain's ability to rewire itself, takes place. From a systems neuroscience perspective, emotional regulation involves a network that includes the prefrontal cortex, responsible for conscious control and planning, the amygdala, which assigns emotional significance to experiences, and the anterior cingulate cortex, which monitors conflicts and errors. In individuals who practice meditation regularly, functional MRI studies show reduced amygdala activation in response to emotional stimuli and increased prefrontal engagement. In other words, they still feel emotions, but their brains don't react as intensely, and they have more top-down control over how they respond. This isn't about suppressing emotion. It's about metacognition, the ability to think about your thinking. Meditation enhances this by activating the default mode network DMN in a different way. While the DMN is typically associated with rumination and self-referential thought, meditators show altered DMN activity, less habitual rumination, and more intentional self-reflection. This leads to more adaptive emotional responses and less compulsive reactivity. One of the key neurochemical mechanisms involved here is serotonin, a modulator of mood and emotional balance. Serotonin, in levels and receptor sensitivity, can be influenced by meditation through its impact on stress reduction, sleep, and breathing. Elevated serotonin in turn helps stabilize mood and creates a physiological backdrop that supports calm, clarity, and even social bonding. Cortisol, the primary stress hormone, also plays a role. In individuals with poor emotional regulation, cortisol spikes can be exaggerated or prolonged. Over time, this dysregulates the HPA axis, the brain-body system responsible for managing stress. Meditation helps recalibrate this system by reducing cortisol output in response to psychological triggers, leading to a more balanced and sustainable emotional profile. Another fascinating layer to this is the role of mirror neurons, which are involved in empathy and social understanding. When you're emotionally reactive, these neurons can amplify distress in social situations, especially if you're absorbing the emotions of others. Regular meditation helps buffer that response. Studies show increased activation in brain areas linked to compassion and empathy, such as the temporoparietal junction and medial prefrontal cortex, but paired with improved emotional boundaries. This allows you to relate to others without becoming overwhelmed. Practical outcomes of this are tangible. People who meditate regularly report fewer outbursts, faster recovery from emotional upsets, and a more grounded sense of self. They are better able to name their feelings accurately, a psychological skill known as emotional granularity, and thus respond with greater nuance rather than broad reactions like "I'm just angry" or "I'm just stressed." Emotional granularity is directly linked to better mental health outcomes, lower anxiety, and more effective interpersonal communication. Even brief daily sessions of 10 to 15 minutes can begin this transformation. As with any neural training, consistency matters more than duration. The repeated act of noticing a thought or feeling, labeling it, and returning attention to the breath or body is what strengthens these circuits. Over time, the brain begins to default to this regulated mode even outside of meditation. Ultimately, meditation allows you to build observer self, a part of the mind that can witness internal experiences without being swept away by them. That ability doesn't eliminate emotion, but it puts you in the driver's seat. You begin to respond instead of react, to reflect rather than impulsively act, and that's not just psychological growth, it's measurable neurobiological change. In a world that constantly pulls your attention outward, meditation brings your awareness inward, and from that place of centered awareness, real emotional intelligence begins to emerge.